Imagine you're sitting in a dark room. The lights are off. In front of you, a single candle burns quietly. The flame leans to one side, then straightens, then flickers again. It dances without music. You move your hand closer and feel the warmth before you ever touch it. It looks alive. It moves. It breathes. It consumes. But here's the question almost no one stops to ask. What exactly is that glowing thing in front of you? Is it a solid, a liquid, a gas, plasma, or something else entirely? Because something this familiar shouldn't be this mysterious, and yet it is. If you enjoy uncovering the hidden truths behind everyday things, make sure to subscribe and leave a like. Here, we turn simple curiosity into real understanding. Now let's look closer, because what you think fire is probably incomplete. Most people believe fire is a thing, a substance, something that exists on its own. But here's the surprising truth. Fire is not a thing. It's an event. It's not an object you can hold, store, or collect. Fire is a process, a chemical reaction happening so fast and so energetically that it becomes visible. What you see when you look at a flame is not stuff. It's energy being released in real time. For fire to exist, three ingredients must come together: heat, fuel, and oxygen. This is often called the fire triangle. Remove any one of the three, and the flame disappears instantly. Think about a piece of wood. It looks solid and stable, but when you bring a lit match close to it, something invisible begins to happen. The heat breaks apart the complex molecules inside the wood. Before the wood truly catches fire, it starts releasing gases. And this is where most people get confused. The solid wood itself isn't what's actually burning in the flame. It's the gases released by the heated wood reacting with oxygen in the air. That reaction happens extremely fast, and when it does, it releases energy. Some of that energy is heat, but some of it is released as light. That glowing, flickering shape you see is made mostly of hot gases emitting light as their atoms and molecules get excited by the energy of the reaction. In other words, you are watching matter transform and release energy at the same time. Now here's something that surprises most people. The yellow part of a candle flame isn't just hot gas. It's tiny particles of carbon, called soot, that become so hot they start glowing. Think of them like microscopic embers floating in the air. They heat up to the point where they emit visible light, just like a piece of metal glows when it gets extremely hot. That's why candle flames often appear yellow or orange. But when combustion is cleaner, like in a well-adjusted gas stove, the flame looks blue. That's because there are fewer glowing soot particles. Instead, the blue color comes from excited gas molecules emitting light directly. Blue flames are usually hotter and more efficient. Orange flames are cooler and filled with glowing carbon particles. The color alone tells you something about how complete the combustion is. You may have heard someone say that fire is plasma, the so-called fourth state of matter. That's partially true, but only under certain conditions. In extremely high temperatures, like in lightning or a welding torch, some of the gases can become ionized, meaning atoms lose electrons and become electrically charged. That's plasma. But the flame of a normal candle isn't quite hot enough for that. It's mostly just hot gases and glowing soot particles. So while plasma can be part of fire, it isn't always. And then there's the flickering. Why doesn't a flame stay perfectly still like a light bulb? Because fire is incredibly sensitive to its environment. Hot gases rise. Cooler air rushes in to replace them. Tiny changes in airflow constantly reshape the flame. It bends, stretches, pulses, and dances because it is always reacting to movement around it. Fire is never static. It responds instantly to the world surrounding it. Which brings us to a strangely poetic question. Fire seems alive. It grows, it spreads, it consumes. It even dies when it runs out of fuel, but it isn't alive. It has no cells, no DNA, no biological reproduction. It doesn't want anything. It simply follows the rules of physics and chemistry, and yet it feels organic, almost intentional. So what is fire really? It's heat, it's light, it's energy being released as matter transforms. It's not a substance you can hold, it's a visible reaction, a transformation happening fast enough to glow. And the next time you strike a match or sit by a campfire, remember, you're not just looking at a flame. You're witnessing atoms rearranging, bonds breaking and forming, energy escaping into the air as light and warmth. And this is only the beginning of what fire really is. Now let's go deeper, because understanding what fire is only half the story. The real fascination begins when we ask why it behaves the way it does. Take the shape of a flame. Have you ever noticed how a candle flame forms that familiar teardrop shape? It's not random. Gravity plays a quiet but powerful role. As the reaction happens, hot gases become less dense and rise upward. Cooler air moves in from below to replace them. That constant upward flow stretches the flame into that elongated shape. But here's something fascinating. In space, where there is almost no gravity, flames don't look like teardrops at all. They form small blue spheres. Without gravity pulling hot gases upward, the flame spreads evenly in all directions. Same chemistry, completely different appearance. This is where most people get surprised. Fire doesn't have a fixed shape. Its form depends entirely on its environment. And what about temperature? Not all parts of a flame are equally hot. In a candle flame, the blue region near the base is typically the hottest. That's where fresh oxygen mixes efficiently with fuel gases. The yellow glowing region, filled with incandescent soot particles, is actually slightly cooler. It looks brighter, but it isn't necessarily hotter. Brightness can be deceiving. The most intense heat is often hidden in the less visible parts. Now think about how quickly fire reacts. Blow gently on a candle and it leans away. Blow harder and it goes out. Why? Because you are disrupting the balance of the fire triangle. Too much moving air cools the fuel below its ignition temperature. The chemical reaction can't sustain itself. The flame disappears instantly, not because it decided to stop, but because the precise conditions that allowed it to exist are gone. Fire is incredibly dependent. It only exists in balance. Too little oxygen, it suffocates. Too much airflow, it cools. Too little fuel, it fades. It's a delicate dance between energy and matter. And this fragility is what makes it so powerful and so dangerous at the same time. Here's something even more intriguing. Fire has shaped human civilization more than almost anything else. It allowed early humans to cook food, making nutrients easier to digest. It provided warmth in freezing climates. It offered protection from predators. It extended the day beyond sunset. Entire industries, from metalworking to engines, rely on controlled combustion. The modern world still runs on versions of fire, whether inside a car engine or a power plant turbine. We may not always see the flames, but the chemical reactions are still there. And yet, despite all our scientific understanding, fire still feels primal, hypnotic, almost spiritual. There's a reason humans can stare at flames for long periods of time. The movement is never repetitive. It's chaotic but structured, predictable but always changing. Our brains are naturally drawn to that kind of motion. So is fire alive? No, but it imitates life in fascinating ways. It grows when fed. It spreads under the right conditions. It dies when deprived. It consumes energy and transforms matter. It behaves like something with intention, even though it has none. It's simply chemistry unfolding at high speed. And maybe that's the most beautiful part of all. Fire reminds us that even the most ordinary things around us are powered by invisible laws we rarely stop to think about. That small candle flame is not just decoration, it's atoms rearranging, it's bonds breaking and forming, it's energy changing form before your eyes. So, the next time you light a match, sit by a fireplace, or watch sparks rise from a campfire into the night sky, remember what you're truly seeing. Not a thing, not an object, but a process, a transformation, a visible reminder that matter is never static, it's always capable of becoming something new. And when you understand that, fire stops being just heat and light. It becomes a story about change itself. If this made you see something familiar in a completely new way, make sure to like, share this video with someone curious, and subscribe for more explorations like this. Because sometimes the simplest things hide the most misunderstood truths.